Okay, now we have already studied about the addition polymers, and we discussed different polymers in detail, like you have polythene, polypropylene. Now let's understand and let's have structure of few of the condensation polymer. Now what exactly do you mean by condensation polymer? Condensation polymers, they are those polymers which are obtained due to condensation reaction. Okay, so you have these polymers are obtained due to condensation reactions. Now, condensation reactions are those reactions in which small molecules like water, it could be something like an alcohol, it could be something like ethylene glycol, it could be something like an acid, that is HX, are eliminated from the big molecule. Okay, so now let's understand couple of condensation polymer. So let's start our discussion with something what you call it as nylon. Okay, now in nylons, basically we are going to study two types. First is nylon 6 and then you have nylon 66. So I would call it as nylon 6. So from where do you get this nylon, right? So nylon, in this nylon, NY stands for New York, and LON, it stands for London, and 6 means number of carbon atoms in the monomer chain. Okay, so now let's discuss in short the structure of nylon 6. So nylon 6 is obtained from epsilon caprolactam. So the monomer is epsilon caprolactam. Now, as the name suggests, capro means 6 carbon acid and lactam means it has to contain something like CONH in a cyclic form. So now let's try to put down the structure. So it is nothing but C double bond O. This is connected to alpha carbon. Then you have the beta carbon. Then you have the gamma carbon. Then you have the delta carbon. So you have 1, 2, 3, 4, right? And then you have the next carbon. And then, so this is 1, 2, 3, 4, 5. And then you have NH. Okay. So how is this molecule obtained? You might be having a carboxylic acid over here and then NH2 over here. So intramolecular condensation will give you something like a caprolactam. So this caprolactam is obtained when you have something like carboxylic acid framework and NH2, they condense to form CONH linkage. Okay, now what exactly happens? So in this case, this polymer is formed when epsilon caprolactam is heated. We could write inert atmosphere in presence of a catalyst, or depending upon what the reaction condition is. So now let's write down the structure of the polymer. So the bond gets cleaved from here, and then you have C double bond O. This is connected to 1, 2, 3, 4, 5. So you have CH2 5 times, and then you have NH. Okay, so this is nothing but the polymer. So if you start with N such molecule, you will get a polymer containing N, right? So this is nothing but nylon 6. Okay, so nylon 6, as most of us are already aware, this can be used in fabrics. These are used in nylon threads. And of course, what are the properties of this polymer? Properties of the polymer will be same. That is, it is chemically inert. It is resistant to acids, dilute acids and alkalis. And then you could say that it is a linear polymer basically, and it is nothing but a condensation polymer. Okay, then you have the next one. It is nylon. It is another nylon, but the name of this nylon is nylon 6,6. So as we are already aware, and NY stands for New York, LON stands for London, and 6,6 means there are two monomers, and each monomer contains 6 carbon atoms. Okay, now let's have a look at what all what is a monomer? The monomer is this compound. You have CH2 4 times, that is methylene, and then you have C double bond O, OH. So this is carboxylic acid. You have one more carboxylic acid. So you have tetramethylene dicarboxylic acid, plus you have CH2 6 times, that is hexamethylene, and then you have NH2, NH2. Okay, now so what exactly happens in this case is these two, this is an acid, this is a base, so they form a salt. Okay, so this is nothing but tetramethylene dicarboxylic acid, and this is hexamethylene diamine. So they form nylon salt basically. So what exactly happens is this H is transferred from here to here, and this H is transferred from here to here, as a result of which you get a structure like this. Now let me put this fragment on this side. So you have NH2, right? NH2 gets a proton, so it becomes NH3 plus. Okay, and then this is connected to CH2 6 times, and then you have this NH2, again it takes up a proton, so you get NH3 plus, and then you have O minus because O has lost a proton, and you have C double bond O, this is connected to CH2 4 times, and then you have C double bond O, and then you have O minus, right? So this is the structure. So as you could already see here that this contains 2 positive charges, so it has to contain 2 negative charges. So now what exactly happens is it undergoes dehydration. So this you call it as nylon salt. Okay, so this undergoes dehydration wherein 2 hydrogens from here and 1 oxygen from here go in the form of water. Similarly, you have 2 hydrogens from here and 1 oxygen from here goes in the form of water. So 2 hydrogens are gone, so you have NH, and then you have CH2 6 times, and this is connected to N. Again 2 hydrogens are gone, so you have N is connected to H, this is connected to now this O is gone, right? So you have C double bond O, then this is connected to CH2, and this is connected to C double bond O, and then this O is already gone, this O is already gone. So what you could simply say is that you are left with this CO, and then this is the growing chain. So this is nothing but the polymer nylon 6,6. So now let's try to put this. You have n such molecules, you will get the polymeric chain, and if you observe, there is something very special, something special about it. In this case, you have CONH. This linkage is called as amide linkage. Okay, so the polymer nylon 6,6 is also called as polyamide. Okay, so this is generally called as polyamide fiber. Now let's have a look at the properties. The properties are the same. It is chemically inert, resistant to heat, resistant to chemicals, that is dilute and concentrated acids as well as base. And then what you could do is it is it is also resistant to water. So you can use write down the uses. It is used in swimwears, fabrics, etc. Nylon threads as well you have, and it has a lot of other uses as well. So this was, and the most important thing, it's a condensation polymer, and since it contains 2 different monomer, it is a copolymer. Okay, let's move on to the third polymer, that is terylene. Now terylene is again a condensation polymer, and it is a copolymer. Okay, and then let's have a look at the monomers. So the monomer is CH2, CH2, and then you write it as OH, OH. this is glycol, ethylene glycol. And then you have another monomer, which is, so this is benzene. This benzene is connected to COO. Now just imagine if you have an H over here, this will become terephthalic acid, right, or 1,4-benzene dioic acid. So I'm putting here CH3 because then it would undergo something like a loss of an alcohol molecule. So what exactly happens? This is called as dimethyl terephthalate because it's an ester. Okay, now what exactly is going to happen now? Now you have this OH. You could simply say that this H and this CH3 goes off. You could say that OH and this OH, or this, either this OH and CH3 goes, or you have H and CH3 goes off. Similarly, you have one more molecule over here, so I could write it as HO CH2, then you have CH2, then this is connected to OH. Now what is going to happen? So you have when this reaction takes place, so I would just draw a dividing line here. So you have HO, this is connected to CH2, this is connected to CH2, and then you have the next fragment. So you have CH2, OH, and then CH3. So this is connected to O, and then this is connected to C double bond O. This is connected to the benzene ring. Okay, and then you have C double bond O, and this is connected to O, and this CH3 and OH goes off, or you could say OCH3 and H goes off, and you get CH2, you have CH2, and this is OH. Now what exactly is going to happen here? You have now one alcohol molecule, like you could say two CH3OH molecules have been eliminated. Now still this is not the polymer, so you take n such molecule, and then you have this OH and this CH2OH go in the form of a glycol, that is CH2OH. If you recall the definition of condensation polymer, small molecules like methanol, it could be a glycol, it could be any alcohol, a small alcohol, as well as you have HX, you have water, these are eliminated. So finally you get the polymer, which is CH2, and this is connected to O. Then you have C double bond O, then this is connected to the benzene ring, and then this benzene ring is then again connected to C double bond O, and then you have O. This is nothing but the growing end of the chain. Since we started with n such molecules, you could clearly write it something like n molecules. So this is nothing but the polymer, or we call it as steriline. So if you observe, this is nothing but an ester linkage, so it is also called as polyester or polyester. Now let's come on to the properties. So properties, basically it is again a linear polymer, it's a condensation polymer, then it is a copolymer. Okay. Now, what is the use? The use is when it is blended with cotton. It forms terracotta, and blended with wool, it forms terry wool. Okay, so it is generally used in fabrics. So this was about the 3 condensation polymer. We have couple of more to do, which we will be doing after this.